Hey guys, so today we are learning about naming ionic and covalent compounds. So we're going to start with ionic compounds. Now, we've already kind of learned how to name ionic compounds, and you should have notes on that. Let me kind of review with you. Remember, you name the cation or the metal that's written first. So if it's just a normal main group cation, so like one of the ones that's not a transition metal, you just give it the same name as the element. So Na plus is sodium. If it's a transition metal though, then it needs Roman numerals. So like iron 2 plus is iron 2, Fe3 plus is iron 3. And then the anion, which is the second element in an ionic compound, if it's just one element, you change the ending of the name to "ide", so chlorine becomes chloride. If it's more than one element, like CO3 2-, then you need to find its name on the polyatomic ion chart, which looks like this. So CO3 2- is carbonate. Okay, so what I gave out in class is basically a flow chart that kind of tells you this same thing. So this is basically just a review of what you've already learned. So we're just going to start doing a few examples. So we're going to start with, and this is on page 50, we're going to start with Na2O. So my goal is just to write the name of Na2O. So I look, Na is not a transition metal, so it's just going to be called sodium. And then O is oxygen, but it's the anion, so I need to change the ending to "ide". So it's sodium oxide. Okay, now I do want to stop here and just remind you, these are the naming rules for ionic compounds. So when we have a metal and a nonmetal, we're going to do some different rules for covalent compounds in a second. But this is just for ionic compounds. So maybe we should label this ionic compounds. Okay, let's do another one. Let's do NaC2H3O2. Okay, so if we want to follow the flow chart, the first thing is to name the cation. It's sodium again, so it's not a transition metal. So it's just going to be sodium. And then the next step is to name the anion. It's not just a single element, it's made up of multiple elements. So I need to look it up in the chart. And we find that C2H3O2 is acetate. So this is sodium acetate. So not too bad so far. Now it's going to get a little bit trickier here. We're going to do CuCl2. Okay, so if I follow my chart, I do the cation first, and Cu is copper. If I look on the periodic table, copper is a transition metal, so it is going to need Roman numerals, and I'm going to have to figure out what those are. I'll explain to you how to do that in just a second. We're going to do the Cl first. So Cl is just one single element. There's two of the same element, but it's just one type of element. It's chlorine. So we just change the ending to "ide". It's going to be chloride. I'm going to leave some space for some Roman numerals in here. Okay, now remember, the Roman numerals are the charge. And this formula doesn't tell me the charge specifically, but I can figure it out. So the way I figure it out is I look at how many coppers there are, and there's one. I'm going to kind of like reverse engineer this table that we use. So I know there's one copper because the formula tells me that, and I know there's two chlorines, and I know that chloride, I know the charge of chloride because it's in the -1 column. So then, since this is a -2 over here, this side has to be a +2, and since I know there's just one copper, this copper has to be a 2+. So it's going to be copper 2 chloride. So hopefully that makes sense how I figured that out. Okay, let's do a couple more ionic compounds. Let's do Cr, NO2, 3. So, Cr, we have to figure out if it's a transition metal or not, and it is a transition metal. I wanted to give you more practice with the transition metals. So, it's chromium, and we're going to leave some space to put some Roman numerals in there. And then NO2 is the anion. It's made of more than one element, so I need to look it up. NO2 is nitrite, and it's a 1-. So, to figure out the charge of Cr, if I draw my 3 NOs out, because I know there's 3 because the formula tells me that, and there's just 1 Cr. This side is -3, so my chromium must be +3. So it's chromium 3 nitrite. Couple more ionic compounds. Ag2S. So Ag is right here. It's silver. And it's a transition metal, so it will also need Roman numerals. S is sulfur, which we name sulfide, because we changed the ending to ide. And now to figure out the charges, I know there's 2 Ag this time, and there's just 1 S. So S is a -2. So since this side is -2, this side needs to add up to +2. That means each of these silvers needs to be a +1. And so it's going to be silver 1. Okay, that's a little tricky because there were 2 silvers. So the Roman numeral is the charge for 1 individual silver. Okay, last one. NH4, 2, CO3. Now this one's a little weird. I wanted to show you this one because I wanted you to remember that there is one positive polyatomic ion. It's ammonium. So this one has 2 polyatomic ions. It's just ammonium, and the other one is carbonate. So you just name it ammonium carbonate. All right, so that's how we name ionic compounds. Now, there is an entirely different system for covalent compounds, but it's easier, actually, than naming ionic compounds. So I'm going to explain it to you, and then we'll do a few examples down here. So basically, if it's a covalent compound, you're going to use these Greek prefixes. So you've probably heard the name carbon dioxide. That comes from the Greek prefix for the letter 2, which is di. So that's like carbon with 2 oxygens, is carbon dioxide. So the first element, you need to see if there's more than 1 atom of the first element. So it'll be easiest to follow this chart if I give you an example. So let's go ahead and, before we get into the chart, let's do N2O3. So we look at the first element. The first element is N. And then the question is there more than 1 atom of the first element? If there is, then I use a Greek prefix. So see how there's 2 N's? That means I use a Greek prefix for the N. So it's going to be dinitrogen. And then for the second element, you always add a Greek prefix to the beginning, whether there's 1 or more, and you need to change the ending to ide. So you don't change the ending to ide on the first element, but you do on the second. So we have 3 oxygens, so that's going to be trioxide. Okay, now this is really easy. The thing that people get confused is once they learn these prefixes, people want to start using them with ionic compounds. But as you can see, none of the ionic compounds use prefixes. Okay, so before you name something, you got to figure out whether it's ionic or covalent. If it's ionic, don't use these prefixes. If it's covalent, then you use them. Also, if it's covalent, you never use Roman numerals. You only use Roman numerals if it's ionic and if it's a transition metal. Okay, let's just do a few more examples of covalent. We'll do CO2 since we talked about that. We'll do CO, we'll do a couple more. So CO2. So we ask ourselves, is there more than one atom of the first element? And we look and there's just one. So we say no, so we don't add a prefix. So we just say carbon. Oops, there should be an R in there. Carbon, not cabin, carbon. And then for the second element, since there's two oxygens, we add the prefix di, so dioxide. So carbon dioxide. Let's do this one. Again, the first element, there's not more than one, so we don't add a prefix, so it's just carbon. Now the second one, we always add a prefix, even if there's just one. So with just one oxygen, that's mono, so that's why CO is carbon monoxide. See, now these names should make sense. It's kind of cool. Okay, let's just do a couple more covalent. Let's do SF6. So again, we've just got one of the first elements, so we just name it sulfur. And then we've got 6 fluorines, so that's going to be hexa. And we change the ending to "ide", so sulfur hexafluoride. Okay, we'll do 2 more. We'll do N2O and PCl5, and we'll call it good. So I've got more than one of the first elements, so I am going to use a prefix. It's going to be dinitrogen. And then just one O, so it's going to be monoxide. And then PCl5, again, there's just one of the first element, which is phosphorus, so phosphorus. And then 5 chlorides, so that's going to be pentachloride. Phosphorus pentachloride. All right, so that is how you name ionic and covalent compounds. I know that was kind of a long video, but that was kind of a lot of information we have to cover. But just follow these flowcharts and you'll be great.